Hello and welcome to today's lesson. In this first tutorial, we will begin to solve rational equations using the LCD. We are in section 8.6 in our textbook if you need to reference that. We're going to first begin by looking at the 4 steps needed to solve rational equations. Now remember, we're talking about equations, so we will have rational expressions with an equal sign. So it's going to be a little bit different than what we've been doing with our previous operations, adding, subtracting, multiplying, and dividing. If you get lost anywhere during this process, just refer back to these steps for guidance. So step 1, we must find the LCD of all denominators. Sometimes we're going to need to factor the denominators first. That's very similar to what we've been doing in previous tutorials. Once we've found the LCD, we're going to take that, step 2, we're going to multiply that LCD to the numerator of all of our terms in our equation, and this will cancel out each part of the denominators. Once we are finished with step 2, we're not going to have any denominators. We won't have any fractions left. We'll just have an equation to solve. And that's why step 3 is going to be solve that equation. Solve for the variable. Sometimes it'll be a quadratic equation and we'll have to solve by factoring. But we know how to do that, so that's fine. And then our final step and most important step, well, they're all important, but this is very important. You must check all solutions. Just because mathematically you receive an answer doesn't mean it's going to work. You must exclude, that means take away, that means get rid of any of your solutions that cause the denominator to equal 0. Because we can never divide by 0, those solutions would be called extraneous solutions. Those are solutions that do not work in your original equation, so we have to check for that. So let's look at a few examples in this tutorial. Start with example number 1. We have a rational equation. It's rational because we have fractions, and it's an equation, of course, because we have an equal sign. So step 1 says find the LCD. So I'm going to list the LCD right over here. I'm looking at the denominators. I see numbers first. So I see a 10 and I see a 5. The smallest, the least number that 10 and 5 both go into is actually 10. So 10 is going to be in my LCD. If you have trouble seeing that, understand that 10 is 2 times 5. And since I already have the 5 here, it's really just the 2 that's missing. So there's my 10. So I'll need 10. The only other factor that I see is x plus 1. So that's going to have to be in my LCD as well. So my LCD is 10 and x plus 1. Step 2 says to take that LCD and multiply it to all fractions up in the numerator. So I'm going to multiply it to this first fraction, I'm going to multiply it to the second fraction, and I'm going to multiply it to the third fraction. All fractions that I see. I like to do it sort of slanty up here because sometimes there's not that much room, so I do that. So I multiply to all 3. It's just a step in an equation that I'm able to do. I can multiply all terms by the same thing. I'm choosing to multiply all terms by this LCD. Now what happens is this. My 10 will cancel away with this 10, one from the denominator with one from the numerator, and I'll be left with 9 and x plus 1. Then I see a big plus sign. In the second fraction, the x plus 1 factor will cancel away from that part of the LCD, and I'll be left with 2 times 10, which we know is 20, and then my equal sign. And then in this third fraction, the 5 will cancel away with part of the 10, leaving a 2, because 10 divided by 5, of course, is still 2. So I'll be left with 2 times 2, which is 4, and the x plus 1. So after that step, I am no longer with fractions, I just have a regular algebra equation. I'm going to need my distribution skills, so I'll distribute the 9 and I'll have 9x plus 9 plus my 20. I will also distribute my 4. I'll have 4x plus 4. Now there's no parentheses. Let's gather our like terms. I actually have 29 here, so this is 9x plus 29. And the 4x plus 4. I'm going to choose the left side of my equation to put my variables, so I will subtract 4x underneath its like term over here. So that's gone. I'll have 5x. Maybe at the same time I'll subtract 29 from both sides. So now this is gone, and I'll have 5x equals, this becomes negative 25. Finally dividing by 5, and I have my answer, x equals negative 5. Now before I box that in, again, I must check. I don't need to check to see it works in the entire equation. I really just need to make sure that this number is not going to make any denominators 0. So I look at my first denominator, and nothing's going to make that 0 because that's just a 10. The second denominator, if I plug a negative 5 in here, I get negative 5 plus 1. That is not going to be 0, so that's fine. And of course, nothing can make the third denominator equal to 0 because it's just 5. So this does not make any denominators 0. So I know that it can work as long as my math was correct. And I'm pretty sure my math was correct. Okay. How could my math be incorrect? Okay, I'm your math teacher, so hopefully it's correct. Look at example number 2. Again, let's start with finding the LCD. We have a rational equation. Let's look at the LCD. I see an x minus 1, and I see a 12. And that's really all that I need. I'm going to put the number first because that's usually what we do. So I'll have the 12 and the x minus 1. I'm going to take the LCD and I'm going to multiply it to the numerator of each fraction. Since I've put something next to this x plus 1, maybe it makes sense to put that in parentheses so I don't forget. Now let's see what cancels away. In this first one, the x minus 1 will cancel away, and I'll be left with 4 times 12, and that's 48. And then in my equal sign. In this one, the 12 will cancel away, and I'm left with x plus 1 times x minus 1. That's going to be a FOIL. So I'm going to write that down, and now let's go ahead and do a double distribution here. 48 is here. This is actually a difference of two perfect square pattern. They're exact opposite binomials. They're not opposites, but you know what I mean. The x times the x gives me the x squared. The outer terms would be negative x, and the inner terms would be positive x, so they actually cancel away. So I'll just skip to my last terms, which is negative 1. So now I have this. I know that this is a quadratic equation. There are two ways that I could solve this. Some people are going to come off here and they're going to take the equation. They can add 1 to both sides and get that 49 is equal to x squared. And then when they take the square root, as long as you remember that when you put a square root symbol on there, you take both plus or minus, both the positive root and the negative root of your answer. So you'll get the two answers plus or minus 7. That's absolutely a perfect way to do that. Some people instead are going to take this equation, and since it's quadratic, they're going to want to factor. So they're going to subtract the 48 over to the x squared. And they'll have, well, they'll have nothing over here, so 0 equals x squared minus 49. This is a difference of two squares that will factor into x plus 7 times x minus 7. And in this case, since we know that these both have to be equal to 0, we get our negative 7 and our positive 7. I'll write it as plus or minus 7 again. So there's two different ways to get those answers. Whether you want to do it this way or this way does not matter as long as you get plus or minus 7. I probably should not have boxed them in until I checked them in the denominators, but I've already seen that the only number that can't work is 1. 1 minus 1 would be 0, but 7 and negative 7 will be fine. So there's two examples. Let's look at our third example and final one in this tutorial. This one maybe is a little bit different looking at it because we only actually see one fraction, so maybe you want to put the other ones over 1 so that you see all three fractions. Now let's find the LCD, which hopefully is not a difficult one in this problem because there's actually only one factor that you see that's meaningful in the denominators, and that's x. So I'm going to take and I'm going to multiply all three parts by x. That's my LCD. In the first fraction, nothing will cancel out with the denominator, so I'm just left with x times x, and that's x squared. Then a plus sign. In the second one, that's where the factor will cancel away, and I'll be left with 12. And then an equal sign. And in the third fraction, nothing will cancel away from the denominator, so I'm left with 8x. And there's my equation. This time we have a quadratic equation because of the x squared, but this time we also have that linear term. So we're not going to be able to add or subtract and take square roots. In this case, we have to solve by factoring. I'm going to subtract 8x and I'm going to put it right here in the middle so that my quadratic is in standard form. X squared minus 8x plus 12 is equal to 0. Make sure when you're solving by factoring that your quadratic equation is equal to 0 so that you can use your zero product property. I'm going to factor this. There's only one option for this, x times x. For the 12, we've got 1 times 12. We've got 2 times 6. We've got 3 times 4. The ones that are going to help me are the 2 and the 6. That's going to help me get the 8. So I know x is going to be in the front of each of the parentheses. I still have it equal to 0, of course. The 2 and the 6 are my guesses for the back of the parentheses. This tells me that both of them have to be the same sign. This one tells me that they're both going to have to be negative. This tells me that x equals 2. This tells me that x equals 6. Oops, I boxed it in again. I should have checked the denominators. But there's only one denominator with a variable, and the only number that cannot go there is actually the number 0, and 2 and 6 are not 0. So those must be my answers. Thanks for watching the beginning of this lesson in this first tutorial, and we'll practice more of that. I'll see you in the next tutorial. Thanks a lot. Oh, please, sit down, sit down. Thank you. Bye.